Hey mathematicians, here we go. We are going to be doing clock face fractions, page 35 in our student book. So after you watched the video lessons for clock lessons, lesson for fractions on a clock face from page 34, now you're ready to work on page 35. Now hopefully you've tried this on your own before you're watching this video. And if you need to get through this with Mr. Mac, then this is the place for you. Um, so remember, again, we're using the clock face to help us with fractions that are thirds, sixths, twelfths, fourths. Some kids like to do fourths and even halves, so the two. So all of these fractions, we have a 2, 4, 6, 6, and 3. So those are all fit into twelfths, which is what we can split up a clock face equally by. So number 1A says color in the clock to show the fractions below. Each clock represents one whole. So like before we did on page 34, we're starting with half. Well, we started with a whole on that one, but I'm still using my colored pencil. For this one, you can just use your regular pencil if you'd like. But to show up on the screen, I think it's a little better for me to use a colored pencil. So there we go, just shaded in half of my clock. Now a fourth, remember a fourth is half of a half. So if I know that this is a half going all the way down, I'm going to cut my half in half. So I am going to make this a little darker and shade in a fourth. Remember, a fourth is 15 minutes, a fourth of an hour. 5, 10, 15. Okay, 2/6. Last time we did sixths, we cut our clock into 6 equal pieces. Remember, we started with thirds and then we cut the third in half, which made sixths. So I'm going to do that again. I'm going to go ahead and cut my clock into thirds. Okay, so 1/3, 2/3, 3/3. Now I need to go sixths though, so I need to cut my third in half, each of my thirds in half. So I'm going to cut this third, I'm going to cut that right in half. Cut this third down here in half. And I'm going to cut this third up here in half. So now I should have 6 equal pieces because I'm cutting it into sixths. Remember, the bottom number is the number we cut. We are splitting our whole by, right? That's what the denominator does. So I have 1, 2, 3, 4, 5, and 6. Good, I have 6 equal pieces. Now this is not asking me to shade in 1/6, it's asking me to shade in 2 of these sixths. So I'm just going to shade in 2 of these sixths. So 2/6, well, look at that. 2/6 is equivalent to 1/3. Because remember, this whole piece here that I shaded in was my original third that I had. Okay, same thing with D. We're going to cut these into sixths again. I can just look up here as my guide to this 2/6. And I'm going to cut both of these because I notice that my numerator is bigger than my denominator. So that means it's going to be more than one whole. I actually have 10 sixths. If it was 6/6, that would be one whole. But I have 10 sixths. So I'm going to cut both of these into sixths. Oops, there we go. Pretty close. There's 6 there. Mr. Mac's lines are a little wonky, aren't they? That's a little better. All right, so I have 2 of my clocks that are sixths, and now all I need to do is simply shade in 10 of them. So I have 1, 2, 3, 4, 5, 6. Now I'm at 6/6, and I need 10. So I need to keep going. 7, 8, 9, and 10. There's 10 sixths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, 6. Now, if I look at this and I want to make this as a whole number, just for fun, I'm going to look at this and go, okay, there's one whole. And how many 6 on my other clock? 1, 2, 3, 4. I have 4, 6. So 10 sixths you can also write as 1 and 4 sixths. Okay, 5 thirds. I'm kind of noticing something here with this 5 thirds. So I'm going to break this up, each clock, into thirds. So that clock is thirds. And now this clock is thirds. So you're trying to make you want to make the clocks even. So you want to make each spot, each space even. So they should have 4 dashes in each little section or spaces. So 1, 2, 3, 4. So there's 20 minutes in each, right? Now I'm just going to shade in 5 of these. So I'm going to start up here with this first clock and go 1, 2, 3. Oh, but I need to shade in 5, 4, 5. Okay, so there's 5 thirds. I could also write this as one whole clock, and 1, 2, 2 thirds. Now, if you notice something, look at D and E here. You guys notice something? Look at the clocks. We have one whole. And then this clock goes to the 8, shaded all the way to that would be the 8 on the clock. And this clock is also shaded to the 8. They're equal. So really, what they're trying to show you is this is a reduced fraction. So 5 thirds is the reduced form of 10 sixths. So they're the same. 10 sixths is the same. And we also, did we say that? No, we didn't say that up there. We did know that this was 2 sixths, so was 1/3, didn't we? We noticed that. Okay, number 2. Use the pictures above to help complete each comparison below using greater than, less than, or equal to. Those are the signs. So, for instance, 1/2 is greater than 5/12. We could tell 1/2 is greater than, so 5/12, if I counted, would be this section here. So 1/2 is 1/6 or 1/12 bigger than 5/12. Okay, 6/4 and 1/2. So let me look at my fourths clock here. So 1/2 is one whole and then a half, but 6/4 is also 1/2. Huh, so those are equal. Let me get this. 5/6 and 5/12. Well, when I know fractions, I know that when the numerator is really close to the denominator, ooh, let me get a little closer up so we can see this a little better. And I know when the numerator on the other one is a lot farther away than the denominator on this one, I know that 5/6 is bigger than 5/12. And basically what that's saying is 5 out of 12 is 25 minutes. 5/6, however, is really 10/12. And 10/12 is 50 minutes. So twice, 5/6 is twice as big as 5/12. 10/6 and 1/2. Well, I could see 10/6 right here. So I have 1, and then if this is the half point right here, so this is half here. So if I just looked at 1/2, I would only see that portion of the clock face. But 10/6 goes all the way over here. It has this much extra. So I can tell 10/6 is bigger than 1/2. 6/2 and 6/4. Well, 6/2 I know is, let's see. So 6/2, if I took 6/2, so if I have this half here and I took 6 of them, I would have 1, 2, 3, 4, 5, 6. That was 3 wholes, I counted. So this is really 3 wholes. And 6/4, remember we saw up here on A was really 1.5. So 3 is definitely bigger than 1.5. And then 3/6 or 2/3. Well, 3/6 is equivalent to 1/2, isn't it? 3 out of 6 is 1/2. And 2/3, sorry, 2/3 is really close to a whole. 2/3 is, if I remember, right here with 5/3, I have 1/3, 2/3. So this, where I'm shading in my pencil here, is 2/3. And this is definitely bigger than a half because this is where the half point is. And this 2/3 goes a little further, 10 more minutes further. So 2/3 is greater than 1/2 or 3/6. Okay, subtract these fractions. Hint, think about money or clocks to help. Okay, so 1/2 minus 1/4. So you guys want to think about money on this? I like to do money on this one. $0.50 minus 1/4 of a dollar. 50 cents minus 25 cents, right? So 50 cents minus 25 cents is 25 cents, or 1/4 of a dollar. We could also write that as 25 hundredths. Okay, 25 cents. But 1/4 is the simplest form of that. Okay, 3/4 minus 1/10. I'm going to think about this as money as well, because I know 3/4 is 75 cents, 75 hundredths. Here, I'm going to write that over here. 75 hundredths minus 1/10. And do you remember what 1/10 was worth? 1/10 is 1 dime, and 1 dime is worth 10 cents. We write that as 10 hundredths, okay? So now I have my denominators the same, 100, 100. So those stay this, that stays the same. And then I say, what is 75 minus 10? Blah, 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 65. So 65 hundredths is the answer for that. That can be simplified, but we'll leave that at that. Okay, 1 minus 1/6. All right. I'm going to go back to the other page real quick. So I have 1 whole minus a sixth. If I just take 1 minus, here's our sixth. So if I took this red pie away, remember that's what that's saying. It's asking, what if you took this away? How many sixths would be left? All of these whites are how many are left, the white parts. So 1, 2, 3, 4, 5. There are 5/6 of a clock face left if I took this 1/6 away. So I'm going to go back. 1 whole clock minus 1/6 of a clock is 5/6, which makes sense because 1 clock is 6/6. That's another way to write 1 whole, right? And if I take away 1/6, then I get 5/6. Okay. 2 wholes minus 1 1/4. Whew, okay. So 2 wholes minus 1 1/4. If I look back up here at 1/4, so I'm taking, if we were doing 1 minus 1/4, if I took this away, I would be left with how many fourths left over? I would have 1, 2, 3. 3/4 left over. So if it was just 1 minus 1/4, it would be 3/4. But this is 2 minus 1 1/4, right? So 2 minus 1 is 1. And so now I'm left with 1 minus 1/4. Or you could think of it like money, $2 minus $1.25. Let's look at it that way. $2, that might be easier, right? Minus $1.25. So 2 minus 1 is 1. But now I have to take away a quarter from, I have to take this 25 cents away now. And I am left with 75 cents or 3/4 of a dollar. And we can write it as 75 hundredths too, huh? If it was just 2 minus 1 without this fourth there, can I move my finger a little more? 2 minus 1 is 1, but we have to take that extra fourth away from that whole. That's where the 3/4 come in. A lot of kids will put 1 and 3/4. But if that was the case, we'd be really close to 2 already, wouldn't we? So 3/4 is the answer there. Okay, a certain fraction is greater than 2. The denominator is 8, okay? What must be true about the numerator? Explain your answer. The numerator must be greater than, so a certain fraction is greater than 2. So if my denominator is 8, the numerator has to be at least double of whatever 8 is, because double of that would be 2 wholes. So what's double of 8? If I count by 8, 8, 16. So the numerator must be greater than 16. And why? I'm going to put the numerator, I'm just going to put n, must be greater than 16 because 16 is twice, no, not twice, erase, sorry, is double 8. So anything above 16 will be greater than 2. Well, anything 16 and above will be greater than 2 wholes. 2 wholes we're going to write. And this wholes starts with a W. W-H-O-L-E-S. Okay, pause this as needed. If number 4 doesn't make a lot of sense, I just want you to think about what 16/8 is. If I split a brownie pan into eighths, but I have 16, then that means I would have 2 brownie pans full, so 2 full brownie pans, so 8 and 8 and 8. So 16/8 is equal to 2 wholes because 16 divided by 8. This fraction, that fraction line just means divide. We're going to talk about that later though. So, okay, hope that was helpful. I'm going to stop now. And yeah,